Good day, viewers, and welcome to today's class. I remain your tutor, Mr. Simplicitee. Today, I want to be taking you through a topic called fraction. It's a very basic topic, and we want to learn it together. Let's dive into the class. So, fraction generally refers to a part of a whole or more. Okay, so whenever you have a part of an object, it is a fraction of that total. So a fraction is usually divided into two major parts, which are separated by an horizontal line called the fraction bar. We have the numerator and we have the denominator under the bar. So it's not one thing we want to waste time talking about. Let us see how we can add and subtract fractions easily. In this video, another thing you will learn is how to find LCM, because most of the challenge I've come to discover with many students is being able to get the LCM of a group of numbers. Let's look at our first example for today. So this is very basic. Whenever you add 1 over 5, 2 over 5, fractions like this have the same denominator, it is very easy to solve. The LCM would be one of the denominator. Since the denominator are all the same, 5, 5, we'll pick 1, 5, and then we add the numerator. It is that straightforward. So the solution to this is LCM 5, 1 plus 2. And that will leave me with 1 plus 2 is 3 all over 5. This is the solution to this first one. So whenever the denominator is the same, it's so straightforward. You just need to pick one of the denominator and add up the numerators. Another example, let's assume we are giving this fraction to add. The same thing goes. The LCM is 7 because they are all the same. The numerator 2 minus 5 plus 10. Or you can use your calculator to solve it. So this is 7 over 7 equal to 1. So this is a simple fraction problem. Then I'll take you to another case where the denominator are not the same. When the denominator are not the same, what do we do in that situation? That will be our example 3. So now we have different denominators and we want to solve. So one thing we can do is to look for the smallest number these three numbers forming the denominators can divide. We have a general way we used to do it. We can bring the numbers 2, 4, 8 and start cancelling out, starting from the most smallest number. If I divide them in, to go through by 2, we have 1, we have 2, we have 4, right? If next number I can divide is 2. This is already 1, can be divided again. This is 1, this is 2. 2 can still go in, so we have 1 again, 1 and 1. When we have 1, we multiply the numbers we used to divide. That is our LCM. In that case, my LCM is 2 times 2 times 2, which is 8. So this is how we find LCM of different number. But there's another way you can find the LCM of different number instead of drawing this out and doing all this division. The other way you can find it, especially for an advanced student, is to look at the highest number among the 3 digits or denominators. From here, the highest is 8. So I will ask myself, since the highest is 8, can it be divided by the other numbers? 8 divided by 2 is 4. 8 divided by 4 is 2. 8 divided by 8 is 1. So all of them can divide it. So that is our LCM. Okay? So anytime we pick the largest number and every other number can divide it, that's our LCM. But in a situation where we pick the highest number and the other number cannot divide it, We can also work out something. Let's look at an example before we solve this. Let me say I have 2, 4, 6, for instance. 6 is the highest digit. Can 2 divide 6? The answer is yes, because it will give us 3. Can 4 divide 6? There will be a remainder, so we'll say cannot, isn't it? So what do we do in this case that all the number cannot divide the highest denominator? What we do is we double it and check again. Since they cannot divide 6, 6 times 2 will give us 12. Now let's check. Can 2 divide 12? Yes, it will give us 6. Can 4 divide 12? Yes, it will give us 3. Can 6 divide 12? Yes, it will give us 2. So this is our LCM. What if they could not divide it? What do I do next? I will triple it. Triple the highest number. That will give me 18. And I will check again. Like that. So we start with the number. If it does not work, we multiply by 2. That's doubling it. If it does not work, we multiply by 3. If it does not work, we multiply until it works. Okay, and if you practice it and get used to it, you will not need to do many multiplication before you get your LCM. Okay, so let's go back to the question. We take our LCM, which we have agreed is 8, since all the numbers can divide it. So we take 8, 2 divide 8, 4. 4 times 3, 12. Plus 4 divide 8, 2. 2 times 1, 2. Minus 8 divide 8, 1. 1 times 3, 3. So with our calculator, or by adding 12 plus 2, 14. 14 minus 3, 11. We have 11 over 8 as our answer. So this is how we take the LCM of fractions. If they are the same, you pick one. If they are not the same, you use the highest small digit as a guide to find the actual LCM. So I believe with these 3 examples, I've been able to explain to you how to get the LCM of a simple fraction. I'm going to add a 4th one before we call it a day for this short video. I'm going to add, whenever you have an whole number and a fraction, how do you add or subtract? This is what we do when there are just 2 of them. I'll take that as our 4th example for this video. Let's say we're asked to simplify 1 minus 3 over 4. 1 minus 3 over 4. So if I'm asked to simplify 1 minus 3 over 4, all I need to do, the denominator of the fraction is your LCM. So I multiply with the whole number. 1 times 4, 4. That's all. This remains minus 3. So this will give me 4 minus 3, 1 over 4. To make it convincing, let's take another example where we have 3 over 7 plus 2. So the LCM is the denominator. The numerator remains. You multiply the denominator and the whole number. 7 times 4, 8 times 2, 14. So our answer will be 17 over 7. So whenever it's a fraction and a denominator, you can see it this way: a plus b over c is equal to ac that multiply plus b over c. So with that, you can quickly multiply any fraction that involves a whole number and a fraction. Okay, viewers, we are back again with another one. This is going to be a very quick one as well. And what we want to look at is how we can add and subtract algebraic fractions. When we talk about algebraic fractions, we are simply talking about fractions that involve variables. When we say variables, we are referring to alphabets. Greek alphabet, English alphabet, every other alphabet or symbols that are used in mathematics. Okay, we call them variables. So what we're going to do is that we're going to check different conditions of fractions. Let's take the first. If I'm asked to evaluate a fraction that has the same denominator, the same rule that applies for an ordinary number fraction is what applies here. You take one of the denominator, and you add the numerator. So that will leave us with C, then you add the numerator A plus B. We took one of the denominator and add the numerator. So as you can see, the numerator are not the same, so that's our final answer. Take another quick example. Evaluate 2x over y minus x over y. The same denominator, so the same rule applies. So this will be LCM is y, and we have 2x minus x. 2x minus x is what? 1x over y. So these are answer. Okay, so take note, in dealing with algebraic fraction, we are very careful. We can't just add different alphabet because they are not like 10. So for you to be able to add or subtract, they must be exactly the same alphabet they are dealing with. So this is 2x, this is 1x, so we can subtract. That's why we got x over y. So the next example will be when we have different denominator. So as you can see, different denominator. For algebraic fraction, what we need to do is to multiply the denominator. So this will be equal to p times q, p, q. Okay? For two different denominator, each denominator is a single variable. Take note. What you need to do is to multiply them. After multiplying them, you cross multiply. 2a times q give you 2a cubed. 2b times p plus 2bp. So as you can see, this is the solution. I don't want to simplify further, so we'll stop here. The aim is to be able to take the LCM, then know what to do from there. That's the essence of this video. Okay, then let's take a situation where we are having a multiple variable in the denominator, like 1 over pq plus 3 over r. 1 over pq plus 3 over r. As you can see, they are obviously different. So the same rule applies. What is the rule again? pq times r will give us pqr. Cross multiply 1 times r plus 3 times pq, 3pq. Done. Is that straightforward whenever it is this different denominator? So we have just looked at the same denominators and we have looked at different denominators. Then we can have different denominators with repeating factors. It's better to write an example to explain that. So I have 3 over pq minus a over qr. So what do I mean by repeating factor in the denominator? Q. That's what we mean by repeating factor. So when you have a repeating factor, if you multiply, there will be a power. You ignore the power. PQ times QR is equals to PQ square R. So I don't need the square. That is to say, I'm not taking the 2Q, I'm taking just 1. If it is 3Q, I will take Q cube. I'll take just 1Q. In that case, my LCM here will be PQR. PQR, which is multiplying the denominator by ignoring the repeating factor. Okay? Then when you want to cross multiply, you still the same thing. 3 times QR, because when QR will cancel this, PQ into the denominator will give you R. Okay, so I have 3 times R, 3 R. I think I need to come again with this. I haven't gotten the LCM. What you need to do, which alphabet is not here? R. Use it to multiply 3, give you 3R. Which alphabet is not here? P. Use it to multiply E, you have EP. That's how you take the LCM of an algebraic fraction with repeating denominator, repeating factor at the denominator. Okay? You multiply. If you follow the normal procedure for LCM and you understand it very well, that's exactly what we are doing. Take the LCM, use the denominator to divide whatever you get multiplies the numerator. That's the norm. Let's check. PQ is the LCM. P divide PQ, you have Q. Q times 2A, 2AQ. Q divide PQ is P, because Q will cancel Q. P times 2B, 2BP. Let me apply it. I've gotten the LCM. PQ divide PQR will cancel PQ, remain R. R times 1, R. R divide PQR will cancel R, remain PQ. PQ times 3, 3PQ. The same thing here, PQR is the LCM. PQ divide PQR will have R. R times 3, 3R. QR divide PQR will cancel QR, remain P. P times E, EP. So that's the normal way of doing this here. But I just gave you a shortcut. When I say take one and add the power for the same base, then multiply them and cross multiply for different bases. Then for repeating factor, multiply them but ignore the repeating factor. Now, if you have q squared, q cubed, a squared, a raised to power 4, you ignore the power. That's what I mean. Just take just the alphabets together without repetition. That's your LCM. Then when you get your LCM, what alphabet is missing here? R times 3, 3R. What alphabet is missing here? P times A, AP. So that is it for LCM. Then I'm going to add this to it, similar to the one we did in the last video for ordinary numbers. Whenever you have a whole number plus or minus, all you need to do is to multiply. So my LCM will remain the denominator. So A times C is AC plus or minus B. Always take note of that. It gives you speed when you see a problem with whole number and fraction, regardless of the position of the whole number and the fraction. Let me add this to it. 3b plus 1 over 7a. Our LCM, of course, is 7a. 3b times 7a, 3 times 7, 21. b times a, ab plus 1. So this numerator will always be brought down. So thank you for watching with me. Have a nice day.